Hi museum families, this is Rachel Carpenter, the education manager at the Children's Discovery Museum, and I am doing science activities at home with my kiddos this week, and I thought I would share what we are doing. So here is Henry. He is in 7th grade and he's 12 years old, and this is Elida, and she is 8 years old and in 3rd grade. And it's really hard sometimes to find activities that everyone can do together. But since both my kids are school agers, we are going to try an activity that we do with one of our outreach programs at Unity Community Center. So first, I'm going to ask my kids to do some research. They are going to hunt down their 3 most interesting experiments that they can find on social media or on YouTube or on Steve Spangler or some of the other spaces that they tend to engage in. And we are going to see if any of those are the same. And then we're going to do some research related to them. So this will help us do not only some science standards, but also some English language art standards. So we're going to see if we can look up the source material. We're going to make sure that the information is accurate and valid. And we're going to look at recipes, and we're just generally going to learn about those activities, and then they are going to do that research, and we're going to do those activities. So some restrictions. They need to find activities where the materials are things that we already have here at home. Okay, so this is something that's important for all of you guys. None of us can really be going out shopping extra, so we want to make sure that we're doing activities that we have the stuff here at home. So that's a limit, okay? And it's got to be simple and easy for us all to do. And we have to be able to understand the science behind the experiment. So I'm going to give my kiddo some time to do that research, and then we're going to check back with them.
20 minutes later.
So Henry, which activities did you find?
Okay, I found homemade rock candy. And I also discovered the potato power, so potato battery.
Mm-hmm.
And the instant ice experiment.
Awesome. Okay, so for the instant ice experiment, what source did you find? Where did you find the idea?
I found the idea after I looked up cool experiments that you can make at home. That's where I found all of mine.
Okay.
Other than the rock candy.
And so what's the source website? I can see it up at the top.
Raising Lifelong Learners.
Okay, did you do any research to see if you could find the same activity somewhere else to see if it's a validated experiment?
No.
Okay, that's all right. So that's going to be your next step. So here are our ingredients. We have a pan. We have my wine cooler here, a teaspoon, our salt, our tap water, and an unopened bottle of water, okay? And Henry over here is making crushed ice, okay? We're gonna need a lot of that. So we took all the ice out of our freezer, and he is carefully using my meat tenderizer to break the ice into small pieces. So we have all of our ingredients now. What's the next step?
Our next step is to put crushed ice in the bottom of our wine cooler.
All right, you do that. How much are you putting in there?
I'm putting about 1.5 scoops.
Okay, and then what happens next?
Next, Elida here will then pour 5 teaspoons of salt.
Great. Okay, what happens next?
Next step is to carefully put our purified water into the bottom.
Why is it important that we're using purified water, Henry?
Because if it is not pure, it won't be able, it'll freeze otherwise.
Okay, that's important, everyone. We want the purified water bottle. They did suggest on the websites that we looked at that it be unopened. Okay, so we left it closed.
All right, next step is to pack in as much crushed ice as possible.
And didn't say to put in another 5 after we finish that?
Yes.
Is that the next step?
Next step
All right,
is we-
Elida, remember, where should you be measuring? Awesome. Great job. Up over the thing. That way, if you spill on top of the ice.
Next step is to take our 100 milliliters of tap water.
I can measure it. Alright.
No,
I'm pretty good at it too.
you're gonna want to pour a little extra into that. 5 teaspoons of salt into your tap water.
All right.
Now, the next
Are you
step,
sure you want to use that for this?
yes,
Yep.
is to stir the mixture.
Awesome.
200 of your 100 milliliters of tap water and your 5 teaspoons of salt.
Do you think the tap water should be warm or cold?
I feel that it should be neither. I feel like it should be lukewarm,
Okay.
room temperature,
Why?
as if it were cold, it wouldn't do the process it was meant to do.
What is it supposed to do?
It's meant to sort of act as salt, but to get every other place.
Okay.
And it shouldn't be hot, otherwise it'll melt all the ice.
Okay. So why are we adding salt to the ice?
Because salt melts ice.
Okay. And so why is that important? What do you think the science is that's happening? Why do we want to melt the ice?
So that the ice will pack in and form around the bottle, giving it the best form of getting cooled without freezing.
Okay, so here's a question, guys. What happens to energy during melting?
It starts moving faster.
Okay.
Molecules start moving faster.
All right. And where is the energy coming from because we have it in the cooler?
It's coming from. I feel like it's coming from the what happens when ice is made in contact with frozen water.
Well, here's a question. In this system right here, okay, what is warmer, the bottle of water or the ice?
Bottle
Bottle
of
of
water.
water.
Okay, so if the ice is melting, where is that heat coming from?
It's coming from the bottle of water.
Right.
And probably the atmosphere too.
Only a little bit, remember, because the cooler,
Keeps
Right.
all the cold.
yep, it keeps all the cold in there.
Now, our next step is to pour this very carefully, as not to spill, along the sides of your ice. As you will notice, it will melt the ice rather quickly,
Okay.
as salt water does with regular ice.
Okay, and then what do we do next?
Now, we let this set for 30 minutes.
Oh, I think there's one more step.
Oh,
What are we supposed to put on the top?
that's right. We're supposed to put on even more ice.
Even more ice.
This is an icy project. So
It is-
don't freeze yourself from the ice.
Don't freeze yourself from the ice.
And that's it.
All right, we'll check back with you guys in 30 minutes.
A few moments later.
Okay, so we've waited our 30 minutes and we're going to talk through the science that happened, okay? So what did we add to the ice, boys and girls?
We added salt and salt water.
Okay, so the salt, when we put salt outside on the ice, what happens to the salt?
The salt starts melting.
The salt melts the ice, right?
Yes.
Okay. what happens is that the salt mixes with the ice and it creates salt water. Salt water freezes at a lower temperature. It's got to be colder for it to freeze. All right? So when we add the salt, it makes ice melt. Okay? Now, to be able to melt, it needs heat. Okay? So where do you think the heat is coming from in our system?
The water.
Right. So the heat is moving out of the bottle of water and into the ice so that the ice can melt. All right? But as we can see in here, okay, our bottle of water is still liquid. Why do you guys think that is?
Maybe it's because there isn't anywhere for the for crystals to start forming.
Exactly. Yeah. What did you want to say, Elida?
Because there's probably also no like disturbance.
Yep. So the water has been sitting very still. Okay. And there's no particles in the water for the ice crystals to stick onto and grow. That's part of the reason why we don't want to eat snow, is because at the center of every snowflake is a piece of dirt. Ew. All right. So I'm going to flip our camera around and we are going to pull this bottle out of our cooler. And then we are going to pour it onto our tray here. And we're going to see what happens. All right. All right, guys. Go ahead and pull that bottle out really carefully.
Oh no, it's got an ice blanket.
It's okay. Just pull it out. If the ice falls off, that's okay. It's all on the counter.
Super cool.
Okay.
Oh, it's still water.
It's still water. Is it really cold, Henry?
Oh, it feels
Okay.
very cold.
So open it up.
Oh no, it's not cold enough.
Not cold enough.
Cold enough.
Darn it.
Oh, all right. Well, we'll have to try this again, and we'll let it sit in our icy salt water longer. So, as you saw yesterday, our experiment did not work the way we expected. So, Henry did some more research, and what did you discover, Henry?
I discovered that we were missing a very key piece, which was a single ice cube to pour the water on.
Why is that important? Can you explain that?
Well, it's because that's the base. It's supposed to be the disruption or the base product to create ice.
So there's crystals already in this ice cube, and once the super cooled water hits it, then ice crystals should form in that, right?
Yeah.
Okay, let's see what happens. All right, so now we're going to go ahead and try it out. Henry's going to remove this. So we started a new bottle, and it's been in the ice bath with the salt for over 30 minutes.
It seems that we are actually growing ice, though not as fast as we were hoping. As you can see.
There are spikes. At first, we actually thought it was melting because of our atmosphere, but later we saw that the ice cube was actually bigger and that was actual ice forming.
So, not as cool as the experiment that we saw online, but it did work.
Yes, we have instant ice.
Awesome. Very good. Thanks, guys.